Okay guys, so in the last video, I talked about how I didn't really have much left of this unit. That's true, and this is basically the last thing that I want to touch on for this unit, applications of rational functions. That's what we're going to be doing today. And these are basically just word problems because I know one thing that a lot of people always ask is like, how am I going to use this in real life? Well, here's how we're going to use it in real life with these applications of rational functions. And there are 9 problems here. We're going to do the first 4 together, and then I'm going to let you guys do the other 5 on your own. But I will help you set them up, I think. So anyways, let's look at this first problem. So, my first problem, I have Martin can pour a concrete walkway in 6 hours working alone. Victor has more experience and can pour the same walkway in 4 hours working alone. How long is it going to take them both to pour the concrete walkway working together? So for this one, what we have to do, it wouldn't just be like 6x plus 4x equals, or 6 plus 4 equals x, because you can't just do that. So you can't just have Martin's 6 hours plus Victor's 4 hours equals x, because then x equals 10, and working together is not going to take them 10 hours because there's 2 people, they're going to be getting it done more quickly. So this is why we have to use our rational expressions, or rational equations for this. So Martin can pour 1 walkway per 6 hours. Victor can pour 1 walkway per 4 hours. Together, we don't know how long it's going to take them, but they're still just pouring 1 walkway. We just don't know the hours. So here, the numerator is the number of walkways, and there's only 1 for each situation. There's only 1 for Martin, 1 for Victor, 1 for the 2 of them together. But then the denominator is the hours. So the denominator is 6 for Martin, it's 4 for Victor, and then we don't know how many it is for the 2 of them together. So I have to solve this now. So just like with the last video when we were solving the rational expressions, I have to find a common denominator. And between 6, 4, and x, I know it's going to have an x in it, and then the greatest common, or the least common multiple of 6 and 4 is 12. So this means I'm going to be multiplying these fractions. So if I want to get this 6 to a 12x, I have to multiply it by 2x. If I want to get this 4 to a 12x, I have to get it to I have to multiply it by 3x. And if I want to get this x to a 12x, I have to multiply by 12. All right, so once I take that down here, let's see, 2x times 1 is 2x over 2x times 6 is 12x plus, and then I have 1 times 3x is 3x over 4 times 3x, which is 12x. And then I have 1 times 12 is 12, and x times 12 is 12x. So what I have to do now, just like with the last video, cancel out the denominators, so you can get rid of the 12x because they're all the same denominator now. We can only do that once it's all the same denominator. Just seeing how much space I have, sorry. Okay, so now I can get rid of the denominators. So I have 2x plus 3x equals 12. And then I want to combine my like terms. So I got 5x equals 12. And then I have my calculator sitting right next to me. And to solve for x now, you just have to divide by 5. And x equals 2.4. And 2.4 is the number of hours it's going to take them to pour 1 concrete pathway when they're working together. So 2.4 hours. And there's our solution. So that's all we would have to have for this problem. It's 2.4 hours. And it's not going to take them 10 hours. It's not going to take them a longer time. But if Martin and Victor are working together, it's going to take them 2.4 hours. And I think that's like, yeah, that's 2 hours and 24 minutes. So yeah, 2.4 hours. So that's the answer. X equals 2.4 hours. Let's see. Moving on to the next one, we have an inlet pipe can fill a water tank in 12 hours. So automatically, I have an inlet pipe, so this is putting water into the pipe. So one tank per every 12 hours. But an outlet pipe can drain the tank in 20 hours. This one is a bit different because it has this other pipe draining the tank. So instead of being added, it's being subtracted, and it can drain one tank every 20 hours. If both pipes are mistakenly left open, how long is it going to take to fill the tank? So we know that the inlet pipe is a bit stronger than the outlet pipe because it can fill the tank quicker than the outlet pipe can empty the tank. So that's how we know it's going to be filled instead of emptied at the end. And let's see, it's still just one tank, and we don't know the number of hours. That's what we're trying to solve. So 1/12 minus 1/20 equals 1 over x. So again, just like with the last one, we need to find that common denominator. It's going to have an x in it. And between 12 and 20, I believe the least common multiple is 60. Because 12 times 5 is 60, and 20 times 3 is 60. So I want to turn this 1/12 into a something over 60x. So I am multiplying it by 5x over 5x. This 1/20 needs to be something over 60x as well. And to get 20 to 60x, I have to multiply it by 3x. And this 1/6, I want to get that to 60x as well, or not 1/6, 1 over x. So I need to multiply that by 60 over 60. So once I do that, I have 5x times 1 is 5x, over 5x times 12 is 60x, and then minus, well, 1 times 3x is 3x, 20 times 3x is 60x, equals, and then 1 times 60 is 60, and x times 60 is 60x. And just like with the last problem and all the others from the last time, now that the denominator is all the same, we can get rid of the denominator. So that gives me 5x minus 3x equals 60. So let's see. 5x minus 3x, combine my like terms. That's going to give me 2x equals 60. And divide by 2. And that is going to give me x equals 30. So I have one pipe that's pumping water in, and it can fill it in 12 hours. And I have another pipe that's emptying it, and it could take 20 hours. So for that first pipe to win, for that first pipe to finally fill up the tank, it is going to take 30 hours. And there's our solution. Just a second, because number 3 is going to be a bit different. So yeah, 30 hours for number 2. I'm looking at number 3. I'm just seeing if there are any others like number 3 in this worksheet. Not really. Number 9 is kind of the same, but not really. So yeah, number 3 is a trickier one, but it's okay because we can still do it. So number 3, we have Parker can finish a project 8 days sooner than Nate. It's not saying Parker can finish a project in 8 days. It's saying Parker can finish the project 8 days sooner than Nate. Working together, both people can finish their project in 3 days. How many days does it take each person to complete the project working alone? So, I will let X here represent, well, there are two things we're trying to solve for. We're trying to solve for how many days is it going to take Parker and how many days is it going to take Nate. But I know that whatever Nate is going to be 8 days longer than Parker. So we will say P equals some number of hours. We don't know what P equals, but N, which is Nate, equals P plus 8. And we're trying to solve for P here, basically. So I'll use P as my variable on this one instead of X. So Parker can finish one project. Don't know how many days it is, but I know it's a certain number of days. It's however many days it takes Parker. And Parker is represented by the P. So 1 over P plus, and then we said Nate was P plus 8. So 1 over P plus 8, because it takes Nate 8 days longer. So this 1 over P is Parker, this 1 over P plus 8 is Nate. And then together, it's going to take them 3 days. So they can finish one project in 3 days. So this is the equation that I'm going to have to solve. So let's see, what can I do with this? Between P plus 8, and 3, there is no, none of these share common factors in the first place. I know that a lot of people are probably tempted to say that P times P plus 8, or P and P plus 8 have a common factor of P, but no, they don't, because in that P plus 8, you can't factor a P out of the 8. So it's just P and P plus 8 and 3. So if I multiply these all together, I'll come over here and do that. So I have P times P plus 8, distribute P times P is P squared, and P times 8 is 8P, and then I need to multiply this by 3 as well. So let's see, 3 times P squared is 3P squared. 3 times 8P is 24P. Yeah, 3P squared plus 24P. So that is going to be my common denominator when I'm doing this. So let's see, to turn this 1 over P into 3P squared, or something over 3P squared plus 24P, I'm going to need to multiply it by, let's see, I would need to multiply by 3P plus 24. So 3P plus 24 and 3P plus 24. To get this 1 over P plus 8 to turn into something over 3P squared plus 24P, I would need to multiply it by just 3P. So times 3P and times 3P. And to get this 1/3 to turn into something over 3P squared plus 24P, I would need to multiply it by P squared plus 8P. P squared plus 8P. So now let's figure out what our new equation is going to look like. So I have 3P plus 24 times 1 is 3P plus 24 over, so 3P plus 24 times P is going to be 3P squared plus 24P. And let's see, then over here we have 1 times 3P is 3P, and 3P times P plus 8 is going to be 3P squared plus 24P, and then equals and then I have 1 times p squared plus 8p is p squared plus 8p over 3 times p squared plus 8p is 3p squared plus 24p. So now I have 3p plus 24 over 3p squared plus 24p plus 3p over 3p squared plus 24p equals p squared plus 8p over 3p squared plus 24p. So what I have to do here is, well, now that they all have the same denominator, I can get rid of the denominator. So that gives me 3p plus 24 plus 3p equals p squared plus 8p. So let's see, what am I going to do next? I'll combine my like terms on the left side. So 3p plus 3p is 6p plus 24 equals p squared plus 8p. And then I'm going to subtract 6p from both sides. So I got 24 equals p squared plus 2p. And then I'm going to subtract 24 from both sides. So once I do that, I got 0 equals p squared plus 2p minus 24. So this is a quadratic, and this is why I said number 3 was a bit different than the others, because this one is a quadratic, and I'm pretty sure number 3 is the only one where we have to deal with these exponents. Number 9 maybe, and there might be one that I overlooked at some point, but I don't think so. Okay, so we have 0 equals p squared plus 2p minus 24. Now I need to factor this quadratic. So I need to find two numbers that are going to multiply to be negative 24. They're going to add to be 2. So two numbers that multiply to be negative 24, but add to be 2, are going to be negative 4 and 6. Yeah, so negative 4 and 6. So p squared minus 4p plus 6p minus 24. I'm going to group. Let's see, between p squared and negative 4p, I can pull out the p, and I'm left with p minus 4. And between 6p and negative 24, I can pull out the 6, and I'm left with p minus 4. And then I rewrite this in factored form. So I have p plus 6 times p minus 4, and then we said it was equals 0. So if p plus 6, or actually we have to set each factor equal to 0. So if p plus 6 equals 0, that means p equals negative 6. If p minus 4 equals 0, p equals 4. So there are two solutions to this. However, only one of them works, because if we look at the original problem, we're talking about how many days it's going to take Parker to finish his project. And there's no way Parker's going to finish his project in negative 6 days. Parker can finish his project in 4 days. He can't finish it in negative 6 days. So 4 is the number of days it's going to take Parker. So we will come over here and say Parker 4 days. And we said Parker is finishing his project 8 days sooner than Nate. So Nate finishes 8 days later. 4 plus 8 is 12, which means Nate finishes his project in 12 days. But if the two boys work together, they can finish it in 3 days. So yeah, that's all we have to have. 4 days and 12 days. Ooh, and number 4, I want to do this one together because this one is a bit different. This one is different from all the rest on this sheet, but it is still a rational equation. So The speed of a passenger train is 12 miles per hour faster than the speed of a freight train. So I'm going to have my passenger train and my freight train. I will use P as my variable again, P for passenger, not for Parker this time. And the passenger train travels 330 miles in the same time it takes the freight train to travel 270 miles. Find the speed of each train. So, the passenger train is traveling 330 miles per however long it takes the passenger train to travel that long, or the speed of the passenger train. And this one is different because we're just going to straight up say it equals, and then the freight train is traveling 270 miles, but the freight train travels 12 miles per hour slower than the passenger train. So it's the passenger train minus 12. And this one, we could just give them a common denominator, multiply both sides by, or multiply the right side by P over P, multiply the left side by P minus 12 over P minus 12. But I'm not going to do that because if you remember how to solve a problem like this, what color do I use? Green. We'll use green. Okay, so I just have two fractions equal to one another. There is no addition going on. So in this case, I can just do cross multiplication. Or some of you may know it as the butterfly method. So all I have to do is this P times this 270. So yeah, this P times this 270 is going to give me 270 P. And then I have this P minus 12 times this 330 equals, we'll just say 330 P minus 12. And I distribute that 330. Let's see, so that gives me 330 P, and then my calculators are next to me, so I'll just do 12 times 330 is 3,960 equals 270 P. So let's see, I have 270P equals 330P minus 3960. I'm going to subtract 330P from both sides. So once I do that, I have, let's see, 270 minus 330 is negative 60. So negative 60P equals negative 3960. And then to solve for P, all I have to do is divide both sides by negative 60. So negative 3960 divided by negative 60 is 66. So P equals 66, which means there's my solution. The passenger train, which was P, it is traveling 66 miles per hour. And since the passenger train is 12 miles per hour faster than the freight train, that means the freight train is just going to be 66 minus 12, which is 54 miles per hour. And there is our solution. The passenger train is going 66 miles per hour. The freight train is 54 miles per hour. Right, and that's all we have to have. And like I said, we were going to do the first four together, and then I was going to leave you guys on your own to do the rest. I'm going to help you set up a couple of them, but number 5, y'all can set up on your own. So number 5, I want you guys to set it up on your own, and I want you to solve it as well. Number 6, let's see, I'll let you guys set that one up on your own too, but since it's 100 claims for each of them, so we have Joy can file 100 claims in 5 hours. Steven can file 100 claims in 8 hours. If they work together, how long will it take them to file 100 claims? So previously, it's going to be a similar problem to number 1, but in number 1, we had 1 walkway per 6 hours. Here, we have 100 claims per 5 hours. So it's going to be 100 over 5 plus 100 over 8 equals 100 over x for number 6. And you're going to solve it like that. Okay, a water tank is emptied through 2 drains in 50 minutes. If only the larger drain... Okay, yeah, I will help you set up this one. So yeah, number 7, a water tank is emptied through 2 drains in 50 minutes. If only the larger drain is used, the tank will empty in 85 minutes. How long would it take to empty if only the smaller drain is used? So we have a large drain and a small drain emptying this water tank. So when they work together, it takes them 50 minutes. So they can empty 1 tank per 50 minutes. When the large drain works on its own, it takes it 85 minutes. So it can empty 1 tank in 85 minutes. But we don't know how long it takes the smaller drain to work on its own. So it can empty 1 tank in X minutes. And actually, sticking with the trend of using different variables, I'll just call that S because the smaller drain. And there's only one thing you have to solve for, and that would just be S. And in this problem, I do think it's going to be a decimal. So yeah, this one, you would have to solve it that way. It's just a bit different because instead of the variable being on the right side of the equation, it's on the left side. Okay, number 8. Okay, this one is going to be similar to number 7. So you're going to set that up the same way as you set up as I just set up number 7. Yeah. And then number 9 here, 2 pipes are filling a tank. 1 pipe fills 3 times as fast as the other. With both pipes working, the tank fills in 84 minutes. So with both of them working, we can fill 1 tank in 84 minutes. We don't know, or it's saying how long would it take each pipe working alone. So we don't know either of the pipes individually, but we know that one of them is 3 times as fast as the other. So I have 1 over, P for pipe. So here's my first pipe, and the other one is 3 times as fast. So 1 over 3P. And that is all you're going to have to do for this one. So 1 over 3P plus 1 over P equals 1 over 84. And solve for P. I believe number 7 and 8 will both give you decimals, but number 9, maybe. It's been a while since I've done this worksheet. So yeah, that is all we are doing, and that is basically the way we are going to finish this unit. Number 5, set that up the same way as I set up number 1. Number 6, set it up the same way as I set up number 1, just with 100 in the numerator. And there will be an assignment posted to Schoology soon. Thanks, guys.